Electric discharge caused the formation of Upheaval Dome by R. Hawthorne, Jr., July 10th, 2019. Abstract. This paper will provide evidence that Upheaval Dome, Canyonlands National Park, Utah, USA, is the product of plasma discharge or electrical discharge machining, also known as EDM. Currently, two theories compete explaining the site's formation, the first being a prehistoric salt diaper, or dome, that has completely eroded away. The second theory being that of impact from either a meteorite or even a comet. This paper will provide new evidence that electrical discharge provided the forces necessary to cause the morphology and transition to quartz crystals in the rock similar to those found in meteorites and other tektites. Evidence will be provided from experimentalist Jacob Gable, using a low-pressure chamber to create cratering patterns similar to those seen on the Moon and other celestial bodies without impacts. Information will be provided on fulgurites, or rocks formed from plasma discharge, which melted into glass. Also, how that glass-forming mechanism could be attributed to a new form of the mineral analcime, eponymously named obsession stone, considered to be ejecta from the Upheaval Dome site. Scientists are baffled to this day as to its peculiar state and how the mineral is found in a crystalline structure. 1. Introduction. Upheaval Dome is an intriguing geological formation in Canyonlands National Park, Utah, USA. The formation is 5.5 kilometers across the outer rim and over 500 meters above the floor's core. A writer for the Utah Geological Survey, William Case, writes on the site, quote, Upheaval Dome in Canyonlands National Park, Utah is a colorful, circular belly button, unique among the broad mesas and deep canyons of the Colorado Plateau, end quote. He goes on to say, since the late 1990s, the origin of the Upheaval Dome structure has been considered to be either a pinched-off salt dome or a complex meteorite impact crater. In other words, the belly button is either an outie, a dome, or an innie, a crater. After visiting Upheaval Dome with Dr. Eugene Shoemaker in 1995, I was of the mind that impact was the better model since Dr. Shoemaker took the time to share with me some of his findings. However, recently presented information on the subject of plasma discharge forming craters, causing surface materials to become vitrified, and form of the mineral analcime that is said to resemble devitrified glass, found just outside of Canyonlands National Park, caused this author to research the possibility that Upheaval Dome was created by a massive electrical event. This paper will present evidence of a more plausible theory that lightning created the temperatures and pressures necessary to shock quartz, create craters, vitrify, and then eject the medium from the site. 2. Salt diaper theory. With regards to the pinched-off salt dome theory, according to the paper, Structure and Evolution of Upheaval Dome, a pinched-off salt diaper, the authors proposed that an overhanging diaper of partly extrusive salt was pinched off from its stem and subsequently eroded. Many features support this inference, especially since sedimentary structures that indicate Jurassic growth of the dome over at least 20 million years. They continue, we infer that abortive salt glaciers spread from a passive salt stock during late Triassic and early Jurassic time. During Middle Jurassic time, the Allochthonous salt spread into a pancake-shaped glacier inferred to be 3 kilometers in diameter. This theory has less support lately because any evidence of the salt diaper has washed away. Further evidence from Dr. Brian Creen's Geology of the Upheaval Dome Impact Structure, Southeast Utah, along with Dr. Eugene Shoemaker, posthumously give the evidence of, quote, the top of the underlying salt horizon is at least 500 meters below the surface at the center of the dome, and there are no exposures of salt or associated rocks of the Paradox Formation in the dome to support the possibility that a salt diaper has ascended through it, end quote. This shows that the salt dome theory is losing support. 3. Impact theory and shocked quartz. An impact theory also exists for the formation of the site. Dr. Eugene Shoemaker writes in his paper, quote, Upheaval Dome Impact Structure, Utah, that he earlier supported the cryptovolcanic theory, a theory no longer accepted on the basis of deformation observed near the center of the dome and the results of geophysical surveys. However, over 2 decades he found the evidence supporting the impact theory to be more compelling. Dr. Kreins states in his latter paper, Planar Microstructures in Quartz Grains, fan-tailed fractured surfaces, shatter surfaces, and rare shatter cones are present near the center of the structure. These shocked quartz grains were understood to be by this author at the time the telltale sign for impact material. In 2008, a paper titled Upheaval Dome, Utah, USA, Impact Origin Confirmed, Dr. Buckner and Dr. Kenkman give the evidence. Quote, "We document for the first time shocked quartz grains from this crater in sandstone of the Jurassic Kayenta Formation. The investigated grains contain multiple sets of decorated planar deformation features. Transmission electron microscopy, TEM, reveals that the amorphous lamellae are annealed and exhibit dense tangles of dislocations as well as trails of fluid inclusions. The shocked quartz grains were found in periphery of the central uplift in the northeastern sector of the crater, which most likely represents the cross-range crater sector. This theory was understood by the author to be most supported. The visit to Upheaval Dome with Dr. Shoemaker allowed the author to actually see some of his findings in situ. This provided a strong argument. However, the unresolved issue of what caused the later discussed rock sample of analcime to be in its present form without solid evidence of being impact material caused for further research of a mechanism that could produce all of these features. 3.1 Electricity and shocked quartz. Geologists have discovered in 2015 that lightning causes shattered quartz, tektite-like rock, and other features previously believed to be caused by meteor impact. Rito Guerre, a mineralogist from the University of Pennsylvania, and his team ran simulations where a, quote, moderately strong bolt of cyber lightning struck the virtual rock. It created pressure waves that peaked at about 70,000 atmospheres, well into the range needed to produce shocked quartz. End quote. A geochemist at the University of South Florida in Tampa who was not involved in the study, named Matthew Pasek, was quoted, "The result could cast further doubt on claims of asteroid impacts in Argentina and Australia that relied on observations of shocked quartz. The analysis should serve as a warning to geologists not to rely only on that line of evidence. This definitely shows that geologists need to consider the geological context of their samples." End quote. In Sid Perkins' article, quote, "Lightning can beat up rocks like an asteroid strike, casting doubt on past impacts." End quote. To further elaborate on Argentina and Australia, H.J. Milosh writes in his letter, Impact Geologists, "Beware!" Quote, "More enigmatic occurrences include the EDOI glasses in Australia, which are attributed to an impact, Haynes et al., 2001, but for which no evidence of a crater exists, and glasses from the Argentine Pampas, Schultz et al., 2004, that if taken at face value would imply impact rates vastly higher on the Pampas than anywhere else on Earth. Could these latter two reports really be reflecting lightning strikes rather than meteorite impacts?" 4. Electrical cratering. Electricity in the form of lightning has been documented to cause craters to form. In the Arizona Republic's article, quote, "Intense lightning strikes can carve out craters in Earth," end quote, Clay Thompson writes, quote, "According to Scientific American, a lightning bolt in 1856 near Kensington, New Hampshire, made a crater about a foot wide and 30 feet deep." He continues with another incident reportedly, quote, 8 inches in diameter and 15 feet deep, end quote. These evidences show that lightning can burrow deep, but can it machine wide amounts of surface like a shallow crater? Can it eject fine material from its core? A citizen scientist named Jacob Gable from the YouTube channel ElectroTerravision demonstrates in the pictures below craters formed by electrical discharge in a small low-pressure chamber partially filled with dirt and sand from outside his house. His experiments in the option of this author have created craters similar to Barringer Crater, see figures 4, 5, and 6, and those found on the moon and other celestial bodies in the form of polygonal craters, and quite possibly transient lunar phenomena, or moon flashes, which are also attributed to impacts. 4.1 Vulgarites. In this article, quote, "Here's how ancient lightning strikes can be trapped in stone," end quote, Robin Andrews writes, "Lightning is ludicrously energetic, with the average lightning strike estimated to involve 1 billion joules of energy. With that kind of energy and with temperatures exceeding 2,500 degrees Celsius, you'd expect that it can do some damage to pretty much whatever it ends up striking." End quote. Andrews later adds, "Despite the sudden temperature spike, the targets do cool off relatively rapidly, which means that the melted minerals don't have much time to rearrange themselves. This normally means that the texture of these once melted segments is often amorphous and glassy. These deposits, dear readers, are what we call fulgurites." End quote. In Kimberly Gennaro's open access paper for geology, her team proposes, quote, "For the first time, a mechanism for the generation of glass spherules in geologic deposits through the occurrence of volcanic lightning. The existence of fulgurites provide direct evidence that geologic materials can be melted via natural lightning occurrence." End quote. 4.2. The Obsession Stone. In 1996, rockhound James Wes Hill and enthusiast Robert Hawthorne Sr. presented a strange rock to local geologists for identification. They believed the stone was connected with the Upheaval Dome site in Canyonlands National Park, but wanted more information to assure its value. After contacting scientists from Brigham Young University and the University of Utah, they were unable to identify the rock. Hawthorne sought out some of the nation's leading scholars on meteors. He caught the attention of Dr. William Cassidy of the University of Pittsburgh. Cassidy had never seen anything like this rock before. After examining a specimen, he writes in his letter, quote, "Preliminary observations are that it consists primarily of irregular-shaped, colorless grains of isotropic material, accompanied by rare rounded isotropic grains. Both the irregular and rounded isotropic grains are probably glass." End quote. Sometime after that, Dr. Cassidy, still unsatisfied with the previous attempts to identify the rock after 3 visits to the Smithsonian Institute, he referred Hawthorne to Mike Zolensky, curator of NASA's Cosmic Dust Collection. An X-ray diffraction test was conducted and compared to the numerous standards available. The results came back that the rock was a mineral known as analcime, NaAISI2O6*H2O, a crystalline silicate of igneous origin, with traces of calcite. Zolensky goes on to write, quote, "These secondary minerals have completely replaced the original mineralogy of the samples, so there is just no telling what they originally were. The gross petrography does resemble devitrified glass, but this could have been a volcanic glass." End quote. 5. Conclusion. Scientists have concluded through consensus that only impacts can create the necessary temperatures and pressure needed to form craters and shock quartz. Upheaval Dome has recently been accepted, again through consensus, as an impact crater due to recent findings of shock quartz and specimens in the center of the dome and its perimeter. However, recent findings from the University of Pennsylvania have shown that lightning can produce the temperatures and pressures required to shock quartz. Geochemist Matthew Pasek of the University of South Florida was quoted, "The analysis should serve as a warning to geologists not to rely only on that line of evidence." End quote. Evidence has been provided through Jacob Gable's experiments that electrical discharge can form craters. These craters formed in his lab strikingly resemble craters here on Earth, like the Barringer crater. This paper has provided information on a glass-like stone of the mineral analcime, discovered just outside of Upheaval Dome, yet could be verified as impact material. This sample of analcime was said to possibly be made of volcanic glass, yet volcanic lightning has been shown to form glass out of the ashes. All of the scientists involved agree the stone is unique, but they could not identify what caused this mineral to take its peculiar glassy form. Perhaps the issue of the formation of Upheaval Dome, the crater, can be at last conclusively agreed upon. That lightning machined the crater and left evidence in the form of samples containing shocked quartz and other vitrified material in the surrounding area.